Okay, so notice you have the function f of x equals negative x squared plus 1, and it says that x has to be greater than or equal to 0. That means you cannot pick negative x values in this case. Normally, we want to pick 0 and then 2 negative numbers, 2 positive numbers for you to graph. In this case, it says, nope, you can't pick any negatives. So I'm going to pick 0, 1, 2, 3, and 4. Well, when I plug 0 in, 0 squared 0. The opposite of 0 is 0. 0 plus 1 is 1. Plug a 1 in. 1 squared is 1. The opposite of 1 is negative 1. Negative 1 plus 1 is 0. 2 squared is 4. The opposite of 4 is negative 4. Negative 4 plus 1 is negative 3. Y'all don't let me screw up. See? Y'all can't see what I'm doing. Whoever's watching the video can see me. All right, 3. Plugging in 3. 3 squared is 9. The opposite of 9 is negative 9. Negative 9 plus 1 is what? What? Negative 8. Good. Plug in a 4. 4 squared is 16. The opposite of 16 is negative 16. Negative 16 plus 1 is negative 15. Now I'm going to go graph. I know this is a 10 by 10, so I'm going to go by 2s on my graph, okay? So I'm going to go over 0, up 1. Over 1, up 0. Y'all don't let me graph it wrong. Over 2, down 3. Over 3, down 8. 4, 6, 8. I'm going by 2s. And over 4, down 15. So there's negative 8, 10, 12, 14, 15. Is that graph looking like it should? Remember we talked a while ago, it should be an upside down parabola. The vertex shifted up 1. And it has to be the positive side of the parabola. So all my x values have to be positive. So that's what I have. Okay? And right now, that parabola, that quadratic function, is 1 to 1. That does pass the horizontal line test. That means when I graph the inverse, it should be a function. Now, what is the domain of this function? Remember, the domain of a quadratic is normally all real numbers. Is this domain all real numbers? No, it is not a full-fledged parabola. It's only part of a parabola. Where does the domain start? Remember, the domain are my x values from where to where. Where does it start? Where does it start? Where does my graph start? At 0 and runs across to where? Not down there. That arrow points down, but it's also going out forever. The down's the range, the out's the x value. So what is my domain? Out that way. You're going out that way for domain. Positive infinity. So the domain is 0 included to positive infinity. Remember, the down is the y value. You want the x values. Okay, you're going that way. So positive infinity, 0 to positive infinity. What about the range? The range is from down to up. So what's the range? Where's my lowest y value? Negative infinity up to where? 1. Good. So negative infinity up to 1, and it does include it. Now, according to that right there, we know what this domain and range down here should be. Okay? Let's see if that's what happens. All right, I'm going to come over here. I'm going to reverse my values. I'm going to swap the x's and y's. So I have 1, 0, 0, 1, negative 3, 2, negative 8, 3, and negative 15, 4. So I'm going over 1, up 0, over 0, up 1, over negative 3, up 2, over negative 8, 2, 4, 6, 8, up, up 3, and negative 15, here's negative 8, 10, 12, 14, 15, up 4. So I'm going from here to here. I'm going to dot my y equals x line. Did y'all forget to do that? I see some of you picking your pencils up. Don't forget to do that. Now I'm going to kind of turn it where I can see it. Is that a reflection across that line, y equals x? They are. It is. All right, so let's talk about the domain. The domain of the orange is from where to where? It stopped right here. It started out here. What's my domain? From where to where? Where does it start? Out here where? Out here. I'm talking domain. That arrow's going that way forever. So negative infinity up to what? 1. Good. So from negative infinity up to 1. Is that what that says? Remember the domain and the range swap. Now, what is the range of the orange graph? Lowest y value. Where's that lowest y value? Remember, right there's where we started, and where's it going? Remember, we're going from down to up. What's that lowest y value? 0 up to where? Not out negative, but up positive. So from where? From 0 included up to positive infinities. Good. Is this graph 1 to 1? Is this function 1 to 1? A quadratic is normally not, but by me restricting that domain, I'm only seeing part of it. So when I do that horizontal line test, then I'm only touching that graph in one place at one time. So yes, this function is 1 to 1.